when you were looking.
Okay. Can you guys hear me? Yeah, okay. The one I liked the best for the sample size generator was checkmarket.com/sample size calculator. And I liked that one. I felt like all the ones I looked at were pretty user-friendly. But this one determined the sample size and the sample size margin of error. And it was simple, but also it gave you really simple, user-friendly explanations directly next to what it was asking you, what information you're supposed to put in. So I really appreciated that because I can put in something, but I need to make sure I understand what it is I'm putting in, if that makes sense.
Absolutely.
So I liked that one for sample size.
Okay. Okay. And did you have one for Z-score?
I found 3 that I liked, but they all were fairly similar, but I guess it would have been good calculators. Did anybody else look at that one? Okay. I liked that one because it had the Z-score also from the p-value. And I could have said that totally incorrectly, and I apologize. But it kind of went both ways, right? So anyway, I liked that.
Okay, that's good. Good. Okay, Nicole, how about you?
Let me look. I had the same one for the sample size, I think, as Tiffany did. My different one for the Z-score, I used one that was at calculator.net. And the reason I liked it because it actually showed the graph of the curve after you used it. And so that one, I mean, I think John and I looked and we found 3, and that one I liked just because as soon as you put it in, it just showed the graph, which is visually for me better to understand what we're going through. So that was the one that I used.
Okay, good. Good. Jared, how about you?
Sorry, it took me a second to unmute. So I don't want to be a broken record, but on the sample size ones, I also liked the check market one because it explained what I was actually looking at on the side. There's also one called like clincalc.com that was a lot like the check market one. On the Z-scores, I used that good calculator one was the one that I liked just because it was easy to navigate. It was user friendly. So those are the ones that I looked at. So not when you Google them, I think we all looked at the same ones that popped up there in the first 4 or 5. But that's the ones that I used. So pretty user friendly.
Great, good. You know what? I think that's a good thing if we find things in common that we like. That probably means it's going to be something user friendly. So Shannon, you want to tell us what you found?
Sure. For the Z-score one, I used one at calculator.net that Nicole used. Probably, I liked it. It seemed pretty in-depth, but enough that I could still understand it for where I'm at. And then for sample size, I used one called stattrek.com. And it was free, so it's full of ads, but what it was actually doing seemed to make sense to me. And so I liked the way that it presented it once you put it all in.
Okay, good, good. The StatTrek, I know another one of our adjunct professors in Southwest, she's a capstone instructor, and she, a lot of times when you get down to finally on your dissertation, you're analyzing your data, and sometimes you look and you go, you know, really this data would be better under, and I think I talked with you guys about how there are all the different versions of that will test sort of the same thing, but it's just specific to a certain kind of data. And sometimes when you get your data back, you find out you've sort of got one of those specific kinds, and so there's a test that will work really well. And she uses StatTrek to help her with that a lot. So she's, I know a lot of her students she's directed them toward that. So it has some other good tools in that, at that site as well.
Yeah,
so,
one note that I made at that was you'd have to be pretty familiar with your data and the use of it, that you would get the results you're looking for. But it had a lot of options.
Yeah, well, good, good. That's good to know. Okay, John, how about you?
Yeah, so just like Nicole and some of the others, calculator.net for the Z-score was very user-friendly, and I liked, like Nicole said, the visual aspect of it. with graphs. For sample generator, looked at one from Qualtrics.com, and it was just really easy and simple. So I thought if you had simple something that you could easily digest and easily analyze, that would probably be pretty straightforward because it was pretty pared down, and it just kind of gave you the bare minimum when it comes to sample size. So that was one that seemed pretty user friendly. But I wrote the stat track. Was it stat track that you looked at?
Go ahead, Shannon.
Yeah, it's STAT and then TREK.
Okay.
Yeah.
Thanks,
.com.
Shannon.
Yeah.
And I think Qualtrics is what you said, right? QUALTRIC. That is the survey platform also that we use at Lindenwood. And so that could be a site. I didn't realize that they had that capability, so I need to dig around in there a little bit more as well. So there's a lot of good help out there, and some of it, like you guys were saying, some of them are free. Philip, is that you there with the iPhone this evening?
Yeah, can you hear me?
Yeah, we can hear you. Hey, did you have a chance to look up any of the generators or the calculators?
Yeah, for the sample size calculator, and I don't know if somebody else mentioned this because I was cutting in and out with my internet. It's been acting goofy up here.
I think it's got a heavy load lately.
It's Qualtrics. It's a website. I mean, it's real simple to use, and that's kind of what I like to use, is things that are real simple and straight to the point. I used it with a couple of things I was doing, just playing around with. Since we're doing the homeschool thing, I was playing around with it and plugging in numbers of kids that's doing work, kids that's not doing work, things like that. So I was using some data from that. And then also there was one for the Z-score, which ncalculators.com. It was another one that was real simple. You just plug the numbers in and calculate it out. There's a lot of advertisements on that one, which kind of was a little bit irritating, but you had to keep Xing out of that. And then there was a math portal one too. It wasn't as user friendly as the other one. It was a little bit more confusing for myself to look at with that one there. But I did like the other one a little better. The NC calculator one.
Okay, well, that's good. I'd not heard of the NC calculator one, so that'll be good to add to our repertoire. And so I hope everybody's jotting these down, and you may have several of them work in common. And I think you're right, John. It's a tendency when we're, or maybe it was Jared that said that, when we're Googling stuff, we sort of look and see what we can get to, and I always go for free things, might as well. There are some things that I'll pay a little bit of money for if it's going to give me a length or, of time. Like I went ahead and signed up for the Zoom just so that I didn't have to worry about cutting my time short on classes and some of the capabilities there. But that's fabulous. To me, using these calculators is easier than using Excel. Because with Excel, you keep typing that formula in again and again. And so this way you're entering your values, but you don't have to do writing in the formula or the syntax for Excel. So what I thought we would do after we spend a little bit of time, sharing out what we had used, it sounds like some of you guys have dabbled in this a little bit. And one of the things that I know I asked you to look at the sample size calculators. That's something people get to be really concerned about when they're considering the data pool that they have, who they can reach, how many people they think they might get data back from, depending on the type of study that they're doing. Not only is there the numerical side of it, like we have looked at in the generators, but there's also the research side for social sciences and behavioral studies, like what we're doing in education. And so when you get into advanced research class and you're studying some of the researchers, you'll see that they have some guidance on that too. That's just sort of standard across the board. Of course, we've already talked about in this class how it's good to have a sample size of 30 to be able to do some of the quantitative analysis that we have out there. And so that's sort of a benchmark. When it comes to doing qualitative type review, type study and research, quite often it depends on, how many, well, what the population available to you, what the size is, what a good sample would be. And sometimes it depends on who your advisors are, how many interviews they might want you to do, or how big they might, or I shouldn't say how big, but how many people that might participate in focus groups or something like that. And they'll have a specific number in mind as well. So that's a little bit different because it has to do with the qualitative side of things. But sample size, population, those are things that we are always keeping in mind as we look at our studies and how we want to develop them, how we want to build them. So I thought if you guys were up for it, and I'm going to actually give you an assignment from now to next week to do some, generate some Z-scores. We're going to look at some of those. Just a rundown of what I want us to accomplish tonight. First was to discuss the generators that we've talked about, and then I'm going to open up an Excel sheet and share it with you here in just a few minutes. And I'm going to just, I had sort of thought we might have a full group tonight. I don't know. It looks like I know one person had said they might be running late this evening, but as people trickle in, and I do have this recording tonight. Last week, I don't know what happened. My recording did not hold for some reason. And I know we received a message from Lindenwood that the cloud base was full on some of this stuff, but I don't know that in the past, that's not had anything to do with my recordings because I just saved them to my computer, but it did not record. So I don't have last week's class, but I've got it recording right now. It better stay there. I'm going to be very careful with it this evening. But anyway, so first, we've already done the first thing I wanted us to do. We're going to look at some data and do a little bit of that Z-score generation and you can use, when I give you a particular value out of the set, I'm going to give some to each of us, and then we'll come back and populate our results. We'll do that. And then we're going to talk about Chapter 8, which is all about hypothesis testing. And this is an important part of research, of course. And I know that you all have had the chance to read Chapter 8 this week. And we're going to go into it in more depth next week. I think that this is a very important chapter. Tonight, we'll really look only at the first section of Chapter 8 and sort of talk about how we set up the whole idea of hypothesis testing. And then I want to introduce to you the data project that we will have due mid-April. And those will be, the data projects will be based on the data sets that you all collected and developed at the beginning of the year. But I'm going to sort of show you how these things go together and how well, just how the process sort of works together. It's not a perfect fit with what's in the book, but it's close between what's in a mathematical statistical book and a research topic in education, specifically as you're going to use possibly for a sample run for your dissertation type topic. So we'll go ahead and I'm going to share my screen on my Excel sheet with you. Let's see. And so first, actually, I'm going to go to this sheet that's called apples and oranges, because we've talked about that so much, taking some data and comparing it. And so I was just thinking, this is truly a contrived situation, but because we talk about comparing apples and oranges, we're going to change our apples and oranges into two groups of bananas, and we're going to be able to compare them on equal footing. So in the apples category, as you can see here, we have some values, and the values in the what do I have there, five data points. They range from, it looks like 128 to 169. In the oranges, on the other hand, those values range from 12 to 28. So you can see that the ranges are different. So I would be assuming that these have different levels of measurement. And so we're going to assume that apples and oranges have different levels of measurement, and we want to put them on equal footing. So what we're going to do is take our apples and our oranges, and we're going to convert the values under those two z-scores, and we're going to put the scores for the apples in banana group 1, and we'll put the scores for the oranges in banana group 2. So right now I can see 1, 2, 3, 4, and let's see. Hi, Casey. Casey's joined us, and Tiffany, and we've got Philip also. Philip, do you have access to be able to get on your computer and do some stuff with the generator right now? Philip, can you hear me?
Yes, ma'am. I'm here. I can see your screen.
Okay. Are you able to do do some generating? Do you have a computer there that you can use one of the generators and do some z-score conversions?
I do not have one with X. Are you there? Can you hear me?
Yeah, I can hear you. Yeah.
I do not have one with Excel with me right now. It's
okay.
I was using my desktop in the school, and right now we're not really allowed to go back into school.
Yep.
So
okay.
My daughter today just brought all her stuff back from college, so I think she has Excel on her laptop that she used in college. So I'm planning on using that. If not, I'm gonna find a way to get back in the school, grab the laptop I've been using and use it. But I can see your screen, but I don't have access to Excel right now. I'm sorry.
Okay. All righty. Then I'm not going to give you any data values to convert. But you can watch along, and I'm assuming since you've played around with that you are comfortable with doing that. So I'm gonna mute you back again, and then I'm gonna assign some values to different people. Okay. So I've got Casey, Tiffany, John, 1, 2, 3, 4. I think I've got 6 people. Is that right? Let me go back up here. Yep, I got 6 people. So let's do this. Okay, we'll start. Nicole, I would like for you, and I need to point out to you guys, under the apples, I just happen to know that the population mean for apples is 118. And the standard deviation is 10. And I happen to know that the population mean for oranges is 18, and the standard deviation is 5. Okay? So here's what I would like to do. I've got 10. So let's do this. Nicole, would you do a conversion for 132 apples and 169 apples? And then you'll report back to me in a minute, and I'll fill that in. And then Shannon, would you do 146 apples and 128 apples? And Jared, if you're lucky, if you do 129 apples, that would be fabulous. And then John, I would like for you to convert 17 oranges and 12 oranges. And then Tiffany, I think you're next up. If you will do 28 oranges, and since John's doing 17 oranges already, we don't have to do it again. So Casey, if you would use one of those Z-score converters. Did you find any of those? Did you look for those? You probably didn't. You weren't. Or, yeah,
I'm going to be completely honest with you.
yeah,
I'm very not prepared for tonight. I've been on back-to-back Zoom meetings all day.
Oh my gosh. I was sort of like,
I know everybody's in the same boat, so I apologize, but I am not prepared.
okay, you don't worry about it because Tiffany's going to pick up and get the 27s, and she's just doing, okay, she'll get for us for the Z-score for 28 oranges and for 27 oranges, okay? And I'll give you guys just a few minutes here, and we'll start putting those in whenever you guys get ready. I'm going to...
So just to clarify, we're doing the Z-scores?
Yes, you're finding Z-scores for these raw values. The raw fruit values, you're going to find Z-scores for them. And when you are ready, you can just sort of wave at me and I'll take your information. And I'm seeing, I need to move me off and look at other people instead of. Okay, John.
Right, for 17, it should be negative -0, or excuse me, negative 0.2.
Negative 0.2.
Correct.
Gotcha.
And then for 12, it should be negative 1.2.
Okay. Negative 1.2. And so I can put, oh, something changed on me. What happened here? Did all my values change over here?
Yeah.
I hit some stuff. Let me go back. I've got too many things laying on top of my computer, I think. Oh, shoot. Okay, well, I know up here, those are all, I had randomized that. I'm going to go ahead and put those values in that you gave me.
Okay.
Negative.
There were 2 17s and a 27 and a 28, wasn't it?
I think so. Are the ones over here changing on me also?
Yeah, because I did the first one for apples and it was 132 and then 169.
I should have removed the formula on those before I started working on this. We'll just go ahead and put in the values that we get because you know what you were given. I think the 17 was here, negative 0.2. Okay, and so who else is talking to me? Was that Tiffany?
Yes. For 27,
Okay.
I had negative 9.1. And for 28, I had negative 9.
28 was negative 9.
That's what I had.
Okay. Interesting. Okay. And
Mine was 1.4 for the first one.
okay.
And then it said 30.2 for the second one.
30.2. That's a really huge, something's wrong. Something's wrong with those values.
I figure it out. I'm going to redo it.
Well, that's okay. Let me see.
Ask Tiffany a question.
Uh-huh.
Tiffany, what were your original values?
I had 27 and 28.
Yeah, that doesn't.
Did I plug something in incorrectly?
I think so.
Yeah,
Okay.
I think so too, because we're not getting the right things.
Mine should be 5.1 for the second one.
Okay.
Oh, I know what I did. Sorry to interrupt. I did the population mean of apples and not oranges.
Okay.
I'm sorry. I'll redo mine.
Okay.
Thank you.
You're welcome.
Okay, I have the next two.
Okay, Shannon.
It was 146 was 2.8.
Okay.
And 128 was 1.
Okay. And
And I had 100. I had the last one. 129 apples had a Z-score of 1.1.
okay. Okay. I'm going to remove this, and we'll go back and let's put in, okay, what was the first apple there? What was the value that you converted?
132.
132. And the next one was?
169.
Thank you. And Shannon, could you tell me again?
Sure. 146
Thank you.
and 128.
And the last one was
129.
129. Okay. And then on our oranges, we started off with a 17, didn't we?
17 and then 12.
See, I'm surprised those are well, no, that makes sense. Okay, and then what were the next ones? 28, was it?
We had 20, there's 28, and then I think another 17,
Yes,
and then 27.
and 27.
And I redid mine if you'd like that.
Okay,
Okay, for 27, I have 1.8.
okay, that makes more sense.
Is that sounding better? Okay, thanks.
Yeah.
And then 28, I have 2.
Yes, okay, that makes more sense. Okay, so look at this. Now we are comparing things that we're comparing on the same scale. As far as if we were thinking of this as being the number of apples, the number of oranges, or the value of those things, we can sort of compare how these two scoring groups go. This group, this standard deviation is positive, and if we think of it on the standard normal curve, it would be far to the right, correct? As a matter of fact, everything here is positive. Everything here is greater than the average, the mean of 118, which then that makes sense that they're all positive. And some of them are far away, so they're, if you think about it this way, if my standard deviation is 10, my mean is 118, 169 is going to be 5 standard deviations, a little bit more than 5 standard deviations to the right of the mean. So that makes perfectly good sense. Where this is, the oranges value is actually below the mean of its population, and it is below by a little bit more than 5 standard deviations, so that makes sense that it's negative 1 point something. Okay, so you're starting, do you see how this is, how these are comparing? And now we're able to see, okay, from the mean of the mean characteristic of the group that it belongs to, this is how they would compare to one another. So this group is, I guess if you look at falling below the mean, falling below the norm, this group is not quite as robust as this group would be, correct? You guys follow what's going on there? Okay, so now we've got that idea. I can tell you guys can use those conversion tools. And what I have over here, I just generated some scores, like MPI scores in English language arts. And the reason that I came up with this one was because I wanted us to consider how, you know, sometimes in school districts we'll take on a new intervention or a new curriculum form or some instructional method. Maybe we're going to introduce instructional coaches into a classroom or something along those lines. And we want to see what's happening. Are we improving? Are things getting better? And so we're looking to see if there's a difference. And so I have this, and I know this is going to probably seem tedious to you, but what I want everybody to do, and I sort of color-coded the first ones, what I'm going to assign for homework is for you all to populate these as Z-scores, your year 1 scores, and I've given you the mean and the standard deviation down below for that group. And then here's your second year. And we'll just pretend that these are 30 students in a school district where they've introduced in the second year a new intervention. And I want to know if there's a difference in the means of these. And I'm going to measure that in next week, or actually in chapter 9, we're going to use the same data again, and we're going to see if there's a difference in the means of these two based on z-scores. And we'll use a z-test, but before we do that, I want us to analyze just looking at those z-scores and see what we think. It sort of is like the intro of this chapter where they're talking about the SAT scores, and they're saying, oh, so is that difference really a difference? Is it statistically significant in any way? And so I just want us to sort of start moving toward that way with some data that I call it rolling around in it, that we've actually had our hands on and done some convergence. So this will be one of the things that you'll do for homework for next week, okay? So I will be sharing this with you guys in the assignment after we're done with our class for this evening. So that takes us through the pieces on this that I wanted us to look at together. So I'm going to stop sharing this part of my screen. And we'll come back to this. Hi, Ashley. Welcome. Glad you're here. I said, I was telling everybody, I think I really did capture the recording this evening. I hope that it will hold tight because I wasn't able to download it from last week. So what I would like to ask you to do is to go ahead and open your textbooks to chapter 8. We're going to just take some time and sort of go through some of the information as it is in the textbook here so that we're all on the same page with our language and so forth. And some of the terminology that's in here, we hear talked about a lot, but sometimes the reasoning behind how it's used can be a little bit confusing. So I want us to spend some time looking at this together. I'm on page 414 of the 10th edition book. And some of the details that I'm going to just point out to you because they're the places where I think sometimes it can be confusing to people when they're talking about statistics and thinking about what they will do. We talked last week about how the standard normal curve is what we are discussing when we talk about z-scores, and that z stands for a standard deviation. So when I say I'm positive 1, am I positive 1z, that means I'm 1 standard deviation to the right of the mean. And with a standard distribution, the mean is always set at 0. 1 standard deviation away is z. 2 standard deviations away would be 2z, and so forth, okay? Going to the right, and to the left, it would be negatives of those. And then we discussed how there are certain assumptions that we make about z-scores and about a standard distribution. And to be able to work in that world, we have to have, if we're working with a standard normal distribution, we're good. We need to have 30 data points. There are just some requirements that are there that we may not always have, or we're not sure we have them. As Shannon was saying earlier, one of the tools that she looked at on those converters, it talked about that you have to make sure your data meets certain requirements to use this particular tool. And if not, in the world of statistics, there's always somebody out there who's ready and able to derive a new formula and provide a new kind of test so that we can analyze a different kind of data, maybe than what we had been analyzing in the past. And so one of those is the t-test. And I told you all last week that that one is one that is used quite often in educational research. And so I was going to spend time talking with you about that. And we will be talking about that next week when we look at sections 2 and 3 of chapter 8. And then there are other distributions and there are other tests that are used, but they're not used as often. So we're not going to spend as much time looking and thinking about those. When we do hypothesis testing, where I have an idea in mind, there's something that I think probably is going to be true. And so I hypothesize, just like in science, that this is what I think is the truth. This is what I think is what's happening out there. When I give a hypothesis like that, like if I say, well, normally, I'm going to go ahead and transition this into dissertation world. Instead of stating, I believe that students who have a good breakfast score better or learn better through the day. Let's just say that I'm able to measure both of those things. A good breakfast, I'm going to define it, and learn better through the day, okay? And I'm going to define how I'm measuring that. So that's sort of my hypothesis. But when I'm working on a dissertation, I'm not supposed to show any bias. What I do instead is I want to frame this in the form of a question, like, and I don't want it to be a yes/no question. If it could be a yes/no question, I could say, do students who have a good breakfast score or learn better through the day? But that answer could be yes or no, and we don't want to phrase a question that way. So we want a research question that can't be answered just with yes or no. So I would put it in terms of what or how or, you know, that type of a question. So I might say, what is the difference in the learning of students who have a good breakfast compared to students who do not have a good breakfast? So there, I've got to know how to measure the learning. I've got to define what is a good breakfast, and then I'll know what is not a good breakfast. And then after I've written my research question, I write the hypothesis. And there I would say, students learn better who have had a good breakfast. That would be my alternative hypothesis. Okay? Or students who have a good breakfast learn better through the day. And then my null hypothesis would be the opposite of that. Students who students who have a good breakfast do not learn better throughout the day. Okay, so that would just be the way that we stated. There's this, that they have a good breakfast, they do learn better through the day. They have a good breakfast, but they do not learn better through the day. Okay, and then you test those to see which one is going to end up being true. And I'll tell you, one of the things that students spend a lot of time doing is crafting research questions, getting them just right so that they say exactly what you want to test. And then once you've crafted your question, writing the hypotheses comes out pretty easy, okay? And then when we get ready to test them, and I specifically talked about finding differences in two groups. I would have a group of students who had good breakfast and a group of students who did not, and I would check the difference in their learning through the day. When we do check differences, then those are the types of questions and the kinds of comparisons where we are looking at a t-test or a z-test, but we would normally look at it as a t-test because we don't have a huge population where we've measured breakfast or not and learning or not. So that's why we would have a t-test. When we do the t-test, there are several ways that we can measure to see if there is a significant difference or not. And they mentioned three of those on page 414. There's the traditional method. The traditional method is where if I'm doing a z-test, I find a z-score for the data. If I'm doing a t-test, I find a t-score for the data. And I compare it to a critical score for a t-test or a critical score for a z-test based on the level of significance that I want to achieve. And so we've talked about that whole idea of probability. We've compared the probability under a standard deviation curve with the area under the curve. That whole idea that the distribution of the population and how likely it is that a value will fall in a certain region based on the size of that region. And that's the critical value is the z-score, or the standard deviation, or the t-score of the level of confidence that you want to have regarding your decision you make on whether or not you're going to reject the null hypothesis. So when we have our research question, we write our two hypotheses, then we always test our data against the null hypothesis, and we make our decision about whether or not we're going to reject the null hypothesis based on the t-score for that data set compared to the t-critical score for the level of probability that we're looking at, the alpha value that we're looking at. Another type of method that we can use is called the p-value method. When we are discussing the alpha level, the alpha value, that's usually like 0.05, 0.01, 0.1, and those are decimal values that can be changed to percentage if we wanted to, and it is the value that 1 minus that value equals the confidence level or percent that we're looking for. So if I want 95% confidence in my decision that I make, this says my internet connection's unstable, guys. I don't know why, except everybody's trying to Zoom in the world right now. So we'll see. Hopefully we hang on. Anyway, 95% confidence level will have a 0.05 alpha. A 90% confidence level will have a 0.1 alpha level. And a 90 or a 99% confidence level will have a 0.01 alpha level. Okay, so if you think of it, 99% is 0.99, add 0.01 to that, and that gives us 100%. 95% and 0.05 would be 5%. 95 and 5 adds up to 100. So alpha and probability always add up to 100. Yes, Casey?
So like for our dissertations or like in the education world in general, what alpha score are we shooting for?
The most common one used in education is 95% with an alpha of 0.05. That's the one that's going to be most commonly used. The three that I mentioned to you are the ones most commonly used in research. You can set your alpha level and your p-value at anything that you want to. That's a good question, and that is the usual. Now, finally, the last method that you can use to do the testing is using a confidence interval method. And, you know, we talked about confidence intervals last week. And so if that seems to be the type of decision, a good thing to base your decision on, then there is a method for that as well. But I'm not going to spend much time other than just introducing that to you. So when you are reading a dissertation, because you'll probably look at a lot of them, we've looked at one together, but you're going to look at a lot of them as you go on this journey, you will see times that somebody reports the t-crit value, the t and then CRIT as a subscript, compared to the t-stat, STAT would be a subscript. That is the traditional method. They are comparing the critical value, the statistical value of their set of data to the critical value for a t-test at a given level of confidence. When you see someone talk about that the p-value is less than alpha of 0.05, That's using the p-value method. All of those values that I've just talked about, t-statistic, t-critical, p-value, alpha value, all of those things are in the descriptive statistics summary that you get. I'm sorry, they're in the t-test summary that you get when you run a t-test using Excel. So as you looked through the mathematical work that's done in Chapter 8, you can use Excel to help you find these values. You also can use the table that's in the back of the book, or, we pulled out the little charts last week that had the tables in them. Those values are there for you for the critical values as well. But Tiffany and I had a little conversation about that this week. The t-statistic is what they show you in the textbook. They show you the mathematics to find the t-statistic for a data set that you're working with. And then you compare that to the t-critical values that are in the table that you find in the back of the book, either in the appendices or in the pull-out chart. The pull-out chart, the t-critical values, those are standard values that have been figured by people who knows how long ago, and they've kept them for us to use, to be handy for us if you don't have a calculator or computer. Now we have calculators and computers that we carry with us all the time, so we can use those to find these tables and values. And I was explaining to Tiffany, you guys are all way too young to ever remember in your mathematics books. I can remember in my math analysis and trig book in high school, we had tables in the back that showed square roots of values that weren't perfect squares, because that took us, we learned how to figure those by hand, paper and pencil, but it took a long time. So if the problems that we were doing weren't about figuring square root, we had the table in the back that we could go look up the square root of a number, because we didn't have calculators to just type it in and figure out what the square root was. We were doing everything paper and pencil. And so there were a lot of tables that were figured like that, and they're still including the ones for t-scores and t-values and stuff in the books. So that's why you have all of that there. Okay, so we've talked about what a hypothesis is. We've talked about the null and the alternative. You'll notice that on page 415, they show you some of the mathematical language for representing a null hypothesis and an alternative hypothesis, and they use the H sub 0. When we write a dissertation, we will use that H sub 0 to represent the null hypothesis. And then usually in a dissertation, you'll have 2 or 3 or maybe more research questions. And then the way that in our area that we do that, we have a specific way that we use the H sub 0, and then like H sub 01 means that's the null hypothesis for research question 1. And then H sub A1 is the alternative hypothesis for the first research question. And so I will share with you guys, I'll send I'll just copy and paste some research questions and hypotheses from somebody that's I'm working with right now and send them so you can get a look at what that looks like when you write those out. I'll make myself a note of that to send that. Send RQs with hypotheses. And so that you can see them. But then when it comes to the portion where they've got mu equals 82 on the first one, and that's the null, that the null hypothesis is that the population mean is 82. And the alternative would be that the alternative hypothesis would be that the population mean is not equal to 82. And that's what in this chapter that they're testing all the time is somebody said, this is the way something is, and somebody says, no, it's not. And sometimes they say, I think it's greater, or I think it's less. And if they think it's greater, that's a one-tailed t-test or a one-tailed z-test. If they say, I think it's less, that's a one-tailed z-test. It's just, is the tail to the right or is the tail to the left? If they say, you know what, I just don't think it's 82. It may be bigger, it may be smaller, I just don't think it's 82. Which sort of reminds me of my grandson who's 5 years old now, and you tell him something and he's like, nope, it's not that. It can be anything else, but it's just not what you told me. So that's sort of, I sort of hear his little voice whenever I see these kinds of math equation or mathematical statements now. But then if that's the case, then if you believe that it's not what somebody told you it was, you don't care if it's bigger or smaller. It could be either one and you're going to be happy. That's when we do a two-tailed t-test. If the values fall on either side, then in the critical region or not, then we're making our decision. And so that's what all this mathematical, all these mathematical statements mean. That's what they're talking about there on page 415. So, and then they give you on page 416 some verbiage that you can use, which is handy to be able to look at if you're writing out your hypothesis as a statement, because that's one of the things about using a mathematical book for this is that those mathematical symbols are not going to go into your dissertation. You're going to actually write out the verbiage. So, and then they give some discussion about what a statistical test is, statistical value. And then on page 418, we have our little 4-quadrant chart again with the idea of type 1 error and type 2 error. Now, remind me, have we looked at this type of situation in this class yet? With type 1 errors and type 2 errors? Okay. High school teachers, you know how you teach 7 sections of the same class and you think, have I done this with them already? I'm starting to get that way by teaching statistics every semester. I'm thinking, have I already done this with this group? So, okay, let's take a look at this. I will just ask you, I know that they go into the example of this with someone who's been accused of a crime and they're taken to court, and so we can make decisions. Two ways the decisions we make can be right, and 2 ways they can be wrong. It can be that someone has committed a crime and they're found guilty, and that is a correct decision. It can be that someone has been accused of a crime they did not commit and they're found not guilty, and that is a correct decision. But there are 2 ways that we can decide the wrong thing. It can be that someone has been accused of a crime and they did commit the crime and we find them not guilty. That's an incorrect decision. Or it could be that someone was accused of the crime and they did not commit the crime, but we find them guilty. Is that what I just said? I'm getting myself mixed up as I'm talking through it right now. But you guys, you can follow where I am, I think. I want to ask you another question before we move past this. Have you all seen this 4-quadrant visual used for other things? Have any of you seen the work that Doug Reeves did with this, with professional development and learning and growth in a district and some of those things? Tiffany, you have? Okay, these charts are very handy to use for this type of thing. So here's what is good to do when you are working with your research. So you have your research question, your first research question. And like I was saying, good breakfast, good learning. That's what I think is going to happen. So not good breakfast, not good learning. Those would be my things that were correct decisions. So then I'm looking for what are my type 1 and type 2 errors. There are 2 types of errors. So if I was looking at that and I said, okay, good breakfast, if I put that up by the, oops, I don't want it that way. Hold on. Not a good breakfast would be, if I would say that would be my null, would be not a good breakfast. And that would go, if that was true, that would go up in the upper left quadrant, not a good breakfast. And so if they had a good breakfast, that would go in the upper right quadrant on the top. That would be a good breakfast, okay? And then along the side at the bottom, I'm thinking if they have a good breakfast, then they're going to have good learning. And so I would be looking at good learning being the bottom right, or I'm sorry, the bottom left. Oops, I've got that backwards. That would be not good learning. And the top on the left would be having a good breakfast, or having good learning. I'm getting myself confused again. Okay, so when I'm looking at this, and I'm not putting this in front of you, but if where the type 1 error is above it, I would have not a good breakfast. To the left of it, I would have that they have good learning. And the reason that I'm saying it this way is because my null hypothesis would be that they did not have a good breakfast but had good learning. So when I look at this, my type 1 error would come if I said they did not have a good breakfast, but they had good learning. That would be a type 1 error. If they had a good breakfast, but didn't have good learning, that would be a type 2 error. Okay? And
Can I ask
so,
a question real quick?
yes.
With that, does that kind of tell you that there could be another variable at play? For example, you know, I had a great breakfast, but I didn't learn well. But additionally, I didn't sleep last night.
Exactly. There absolutely can be. And that's what, you know, we talked about when we talked about variables at the beginning earlier in the book, we talked about confounding variables. And so, and I'm glad that you brought this up, John, because it's one of those things that we don't talk about a whole lot. When we talk about research, we want to think that it's absolutely clean and perfect. But we have confounding variables in any research that we do. And so we try to mitigate those confounding variables if possible. If we can't, then we acknowledge them. And so this is another thing that you'll see in a dissertation. There's a section in chapter 1 that talks about limitations, delimitations, and assumptions. And that is a place where you're able to discuss all of the confounding variables, the things you can't control that are going to affect your research that you recognize they do. But for, you know, it's and I another term that I use with this is truth in advertising is what I think of it. When you present your research, your outcomes, you want your reader to also be aware that these could be things that are going to get in the way. And sometimes there are things we can control for, and sometimes there are not, just like that with students. And my example is sort of trivial and silly to make a point. I wouldn't deny students a good breakfast. I wouldn't ever, you know, what I'm saying, that would not be ethical to do. And so it would be difficult to do that study to make it be a real study. But I also wouldn't want I would want to try to be able to ensure everybody had a good night's sleep, but I couldn't really do that either. But those are things that are going to pop up in your research. No matter what you do, how clean you want it to be, even if you take secondary data that's already happened and you pull, you can't be sure. I'm trying to think. Let me think of a topic that somebody's doing right now where it's all secondary data. Oh, okay. I know of one. A student will be doing, their study has to do with, this is at the higher education level, having a librarian embedded in a research course. So like, let's say in capstone 1 and 2, that we had a class one semester and a librarian came in and explained to you all of the resources that were available in the library for your review of literature and for research help and that kind of thing. And, very friendly, very nice, gave you their card, contact information with the times that the library was open and, that kind of thing. And maybe even a little brochure with some things about different resources that you could use in the library. And then the following semester, same course, same teacher, that librarian came like every other class and worked with you when you were, sort of met with you one-on-one. What is it that you're studying? What is it you're looking for in your research? What type of resources do you think you want? Oh, you're looking for this particular journal or whatever it might be. And so you've got somebody that you're talking with and working with all the time. Okay, so then after they're done, their research studies are scored. We want to check and see which ones had the better research studies in the end. Did having an embedded librarian there to help and really develop a relationship and such with the students throughout the semester, you walk into the library and, oh, there's so-and-so. Yeah, we talked in class. Remember that journal I told you I was looking for? Get the idea? Compared to, that's the person who came to our class once, and I think I've got a card. And then did that have anything to do with how the students did on their research projects? Well, it might be very closely and directly related to that, embedding that person in the classroom, or it might not. It might have been that those people just had more time. Maybe they had a COVID virus that kept everybody at home and they could spend all their time working on their research project. Or, it could be other things that happened that caused that, to be the outcome. So you always have to put that information out there. So that's a good question and a good thought. Okay. Any other questions right now on what we're doing or where we're going? No? Okay. On page 419, they also discuss the level of significance, the alpha level. We talk about that. And that's the probability that you will make a type 1 error. We don't want to make any errors. We want the probability of making an error to be very, very small. And so that's why we test the null. We have to remember that when we say 95% confidence level, then we have a 5% level of significance, meaning that, it's very small percent of probability that we're going to make that error, but that's still there. And so there's something I want to talk to you about here that's another dissertation part of this that I want you to recognize. We don't ever accept a hypothesis, because accepting a hypothesis is, it carries with it the thought that we're assuring you that it's true. And we can't do that because we don't have 100% probability of this happening. So instead, what we do is we say we reject the null or we do not reject the null. okay, as we make a decision. If I do not reject the null, then that means that my evidence wasn't sufficient for me to even say that at 95% of the time, I'm confident this is going to be true. If I do not reject the null. If I reject the null, then I'm saying with 95% of the time or 95% confidence, I can say that this is a true statement. So we always leave, there's never that 100% confidence that something that we've made a profound discovery. We always leave that room there because we know that this is all based on probability and theory of probability. Okay, so just keep that in mind when you discuss your outcomes, your results. Don't ever say you accept. Don't ever say something is true. We always say we reject or do not reject the null hypothesis because that is what has been tested. The next few pages, they go more into the idea of the one-tailed or two-tailed tests. They also discuss and talk about a critical and region and non-critical region. The non-critical region, when you look at the diagrams that they have here, that's the region where 95%, the large part of the population lives in the non-critical region. We are always going to be trying to test for a critical area, something unusual. That's what we're looking for. And if we find something unusual, then we are able to reject the null hypothesis. If we find something that's run-of-the-mill and everyday, then we do not reject the null hypothesis.
Can I ask a question?
Yes.
Okay, so in the main part, like if this is a graph, like that's the non-critical region.
Correct.
Then those out, the little tail, you know, on the outside, it's like if it goes past that point,
then you're into,
that's when you would reject it
because your value has fallen into a critical region.
Okay, thank you.
Mm-hmm. And in this book, the critical regions are always shaded gold, it seems like. There are some parts of this that you almost feel like you're dealing with double negatives, you know, as you think about this. It sort of seems like backwards thinking. And this is another thought that I have. Having been a math teacher, I taught geometry. And, you know, in geometry, you do proofs, right? You do those 2-column proofs where you make a statement and then you give a theorem that backs it up and a statement and a theorem that backs it up. And then you get to one part of geometry where you do what they call an indirect proof. Does that ring a bell to anyone? And the idea with an indirect proof, I know some of us have blocked that stuff out as best we could. But the idea with an indirect proof is that there's something I want to prove, that there are so many variations of it, so many examples of it, that I can't prove every single one of the outcomes I want to show are true. So using logic, using the rules of logic, I think, okay, if I can show the opposite of what I want to prove is not true, then I've proven, or then I've shown that what I do want to prove is true. And that's an indirect proof. And I know that probably, I can see eyes sort of rolling around here. But, you know, if I wanted to say, I'm trying to think of a good example. I never can pull them up when I want to. It's so awful. I can't think of anything off the top of my head. Maybe I will when I get ready to email you guys. Something will come back to me that's a really good idea, a really good example of how you can use indirect proof. If it does, I will share it with you. But the idea is to say, you know, if I can prove to you that the opposite of what I am trying, the point I'm trying to make, if I can show you that the opposite of it is absolutely not true, then by the rules of logic, what you're wanting to make a point about would be true, because it's the rest. It's the rest of what can happen. That's bad. Sorry. I've got to think of a good example, and I will. I'll get one for you. I promise. I'll send it to you this evening. Okay. So this is what I wanted to talk about in this chapter, was these ideas. And then I also wanted to talk with you and go with you through, on page 424, the procedure table for solving a hypothesis test, the steps that we have to go through. These 5 steps really mirror what you're going to do in your research project. And so there's a procedure table on the bottom of page 424. And this is what you do as you go through and test hypotheses on your research questions, if you have hypotheses on your research questions. And that will depend on if you're doing a quantitative study or qualitative. So the first thing you do, and this is one of those deals where taking the time to actually think these steps through and write them down serve you so well. And that's exactly what we're going to take you through in Capstone 1 with your prospectus, is steps similar to this, okay? First, you determine what your hypothesis is. What's the topic? And I a lot of times I'll call it the topic, because in a qualitative study, you still have a topic. There's something that you think's going on, and you want to sort of test it out, even though it may not be quantitative testing. So you state your hypothesis, and you identify what your claim is. And your claim is usually your alternative hypothesis. It's the thing that you believe is true. Okay? Then the next thing you do is you find the critical value. So you determine what level of confidence you want. Like Casey was asking, normally what is that in education? You want to be 95% confident. You determine what it is that at the level that you want to be, and you find the critical value for it. So the way I think about this, if you were doing a qualitative study with just perceptions that you've had conversations with people about, is you have an idea about a certain situation, usually what people believe about something, and so you start asking them, and you have in mind particular comments that you're expecting to hear. That's sort of your claim. I'm expecting to hear these things. These are the things in my mind that I'm expecting to hear. That's what you're going to test against. Same thing, if you put those into quantitative values, you give you're using the numbers and you're coming up with a quantitative value that you're looking for. If it's greater than this much, then I know what I'm thinking is right. If it's less than that, then I can't make that claim, okay? Then you compute, I'm sorry, go ahead.
Sorry. This may be a question for another time.
No.
For a qualitative study, for the critical value, there's not really one, is there?
There really isn't one, no. But what it is it's more the idea of it's basically, it's like you're testing your perceptions against other people's perceptions. And it's more of an idea thing. It's not something you're absolutely measuring. You're looking to see possibly more of a frequency of how often are you hearing a perception. Is there something that people perceive about this that comes up all the time that is not at all what I expected it to be? So in that sense, your critical value is sort of what you expect everybody's perception to be. And if they come up with something different than what you had thought was that, it just doesn't jive. And so then you go forward with your study there. But you don't have a value. It's not a numerical value. It's not a numerical test. Once you compare what you thought or what your test value was, if you're doing quantitative, against the critical value, you make that comparison. Based on that comparison, you make a decision. Was my hypothesis about this situation correct or not? And once you make that decision, then you summarize your results. So when I look at this, I think of like your chapter 1 is very much where you are laying the groundwork for, this is what this study is about. Here's the problem that we've got to solve. Here's the purpose of this study. Here's how I'm going to measure these things. And then in chapter 2, you give a whole lot of background information on what other people have done to study that problem. Chapter 3 is you lay out how the test will be done. So at that point, you're just determining which kind of a test you're going to do. Are you going to look for a difference? Are you going to look for a correlation to see if there's a relationship about things? If it's a qualitative study, you tell about, these are the kinds of questions I'm going to ask to see if I can find out more about what people are thinking about these things. And then in chapter 4, that's where you actually reveal what the outcome was, which to me is a lot like the compute the test value and make the decision. And then in chapter 5, you summarize the results. So there's sort of an alignment, in a sense, between these things. Now, in this book, you're going to read about some testing that they've gone through the testing steps, and they will lay them out. Number 1, write your hypothesis. They'll write it in that mathematical language. Number 2, find the critical values. That's going to come from the tables based on your percentage of confidence that you want to have, like we were talking about. And is it a one-tailed test or a two-tailed test? That's going to be part of that. Compute your test value. That's where you look at your data set, you do the mathematical manipulations, you come up with the T statistic or Z statistic, and then you compare it to the critical value. If it was a qualitative study, you compute the test value. That's where you're looking to see, okay, the perceptions of the people that I collected information from, gee, is that what I was thinking it would be? Then you make your decision. Did I find what I thought I would find or not? And then you tell about the results and what you found out of that research. And they go through some of those. I guess they begin in section 8.2 is where they actually begin doing that kind of testing and taking you through the different steps. So the last thing that I have on my list for us to talk about this evening then is I want you to take this idea of those 5 steps, and I'm going to open up, I'm going to share a screen with you from the Qualtrics, not Qualtrics, from the, oh, I think I need to change something here really quick first. I need to go to a different screen. Okay. And now I'll be able to share. This is the Canvas page from the 645 Canvas shell, but it's exactly the same in the 745 shell. I've published this today. This is the data project that is due on the 15th. And we do this each year. And like I said, it's based on, for you all, it will be based on the data that you collected at the beginning of the year where you had the 2 data sets. And so some of this information you've already done, but you're going to create some type of a slide presentation. It could be Prezi, it could be PowerPoint or slides, whatever it is that you prefer to work in. And you are going to describe the topic that you wanted to analyze. And you've already described that to me, but now you're going to present it to the class, and you're going to present it in a way, this is your audience. If you want to, you can define your audience. You can define us to be your colleagues in your PLC group. You could define us to be the board, the school board in your school district. You might define us to be the administrative team in your district, whatever you think would be appropriate. Maybe it's your principal. Maybe what your topic is an issue that you want to talk to your principal about, and so you've taken some data and you're going to analyze it and present to them what you found. So describe the topic. This is sort of like in chapter 1. You're going to tell me what's the problem to be solved, what's the purpose, why are you doing this study. So that will be a slide that you might do. You might do a couple slides on that one for sure. And then next, what's the question you want to answer by analyzing the data related to your topic? And I think you'll remember I said pick something that's been on your mind that you just felt like you didn't have the time to really look at. And so each of you know what the question was you wanted to have answered, so you'll present that on a slide. And then you're going to describe to us, you're not going to necessarily show us an Excel spreadsheet with your data on it, but tell us what is the data that you wanted to analyze. And you guys know what your data is, so you're going to describe that to the class. And then the results of the analysis. And here's where people get to be really worried about things. They want to know, do I have to do a t-test with my data? Do I have to do, what do I have to do? You don't have to do a t-test. You don't have to do a correlation. You don't have to do any heavy statistical analysis from the perspective of like running some kind of a test. You're welcome to if you want to. You can show us frequencies and percentages, show us a histogram, show us a double line chart, something like that. Whatever type of display you think will be good to for us to see, to understand your findings. And then after you've shown us that, you will talk to us about these are the findings. How did you perceive, or how do you perceive the analysis you've done answered the question or questions that you had up above on number 2. So the data that you've collected, what did you find out? Did you get an answer to your question? And I want you to know that sometimes your data doesn't answer your question. So what did you find out? Well, you found out that either the question you had can't be answered by the data that you collected, and there might be other data that would serve better to do that. Or there may be that you just found out that what you thought you were going to be able to state or make a decision about based on the data you had, that just really didn't turn out to be the case. And that's okay, because you have found out, more than you did before about the thing that you're interested in. And the reason that I want us to go through this process is because that happens through the dissertation process also. There are times people will have a hypothesis about something. They think that they're going to be able to show a relationship or show a significant difference or collect data and find out that people believe something. And after they've done that, they don't find that at all. And sometimes people feel like they've failed in some way, but you haven't failed at all. You've done the research, and you've come to find out that what you hypothesized was not true. And so then that means you're just one step further down the road on the research. Okay, so that's why we go through this process. What I would like you to do, you all know how I've done some of the PowerPoints with the voiceover part. Since we are all virtual, we're going to upload these. You can send them to me as a PowerPoint, or you can, I can share my screen with you to do the PowerPoint to present them to our group. But I do want I want everyone to have their project turned in to me by the 15th. It can be recorded if you want to record your voiceover and do your presentation, and keep them at about, probably about 10 minutes at the longest, your discussion. And then we will, on the 15th, we will view some of those. And then the following week, on the 15th of April, on the 22nd of April, we'll view some more. And then the final class time will be another take-home exam, similar to what we had for the midterm. That will be your final exam. So down below here, I have that your project is worth 50 points. Clarity of written information is 17 points. And so I want you to be sure that your slides that you present are all well written, no spelling errors. We can read what's on the screen, that it makes sense. I just want you to give it care, look at it, make sure it's a good, professional, finished product. Clarity of your oral presentation, and then proper formatting of the visual representation of your data. And any of these things that you want to do ahead of time, all of it, if you want to, and send it to me to review first, and I'll give you feedback before you turn it in for the final, would be fine. But it will be final once it's turned in on April 15th. So if you want it previewed ahead of time, you need to get it to me earlier. And then my last comment here is one that I told you this from the beginning. I wanted you to choose a topic that you work with that will inform what you do, that you can get the data, and that it will be meaningful to your work. So hopefully you still feel that way about the data that you collected earlier on.
Questions?
Yes.
If you don't feel that way about the data that you collected earlier on, is it possible, are you okay with us pursuing some different data that may be more relevant at this point?
I absolutely am happy with you to do that.
Second question, can we, if I have it on my computer and I hit share my screen, I can share it on my screen too, right? And then
yes, as long as I give you, if I've set up the Zoom session, if I give you permission, you can share your screen, and I will do that. Does that make sense?
Yeah.
Okay.
And could we talk through that and not have the voiceover as an option?
You can. You can talk
Okay.
it through and not do the voiceover if that's what you prefer.
Thank you.
Mm-hmm. And what I like another thing about what John just asked, because this is something that happens sometimes with dissertations also. You begin with the topic and maybe get along the way, and then you go, you know what? This isn't the right one for me to do. And so you can begin again. There are people who change their topics when they're partly into their, preparing their dissertation and going through the process. So that's another thing that can happen. I love it when things like this come up, when questions like these are asked and we can discuss them and see that this class, I really want it to be like a little tiny example and taste of where you're going to go on this journey, so that you have an idea and don't feel like it's so foreign as you go through the process. Okay, that's what I have for you this evening. Does anybody have other questions? Nope. We're all good for the good of the group? Okay. All right. Well, I will be sending you all an email, and I will be also publishing an assignment for next week. And so you can expect to see that tomorrow. I'm also going to very carefully make sure that I get this recording onto my computer so I can share it with you guys. Yes, question. Ashley?
Yeah, thank you. I lost connection and I joined back on right away, but how long do you want it to be in length so that I don't go over?
Okay, about 10 minutes at the most. Yeah, somewhere between 7 and 10 minutes I think is good.
Thank you.
Uh-huh. Anybody else? Okay, guys. Well, have a safe week. I hope everything goes very well for you this week. We're all getting used to a new way of living. So if you have any questions about anything, please contact me. I'll be happy to talk with you. And have a great week. Enjoy tomorrow. It should be nice out. Bye.
Thank you. Bye.
Thank you. Bye-bye.
Bye.
Bye.
I do too, Caitlin.